Okay, so can you hear me now? Yeah, it's about to start. Okay, so let's quickly jump into the use case. Okay, so let's take a use case and let's try to understand what exactly is DevOps. Okay, and how we are going to perform this on AWS. Okay. Okay, now let me take one of the e-commerce website, the favorite your websites you do online shopping. Okay, let's take the Amazon. Okay, and also I will open in parallel with your one more our Indian e-commerce website. Okay, so let's take this e-commerce websites. Okay, and let's try to understand how exactly DevOps is going to help for these businesses like to Amazon and Amazon e-cart and the Flipkart. Okay, yeah. So let's take this example. Okay, yeah, right. Okay, let's take this is a use case. So this is one organization. Let's take Amazon and Flipkart. Okay, these are the India's most online retail websites. So we used to purchase the required groceries and whatever the electronic items, mobiles, and whatever it may be. Okay, so like how Amazon is and Flipkart is going to deal with this application along with their infrastructure and high availability. So let's write it down. So whenever you design a website, okay, whenever you design a website, you thought company thought they wanted to develop some website. Okay, so and once they develop that website and there will be a purpose. Let's say if it is Amazon and the purpose to sell something so that the end users, like we are the customers for Amazon and Flipkart. Okay, so let's say so their main intention is to sell something. So if so the website should be very responsive, and also it's very high available. Let's say now let's take availability. Okay, availability, and second is performance. Let's take these two factors and understand how exactly so we are taking the use cases of this availability and performance. Okay, we'll talk first about the performance. Let's say you are the end user. Okay, you are the end user, and there will be for Flipkart there will be a big billion days. Okay, they will offer low discounts during some big billion days time. Okay, big billion days time, and there will be a 2 to 3 days period of time. Okay, they will, let's say today is July. Okay, in August 15th. Okay, so we have our Independence Day, and then they will offer some discounts between August 13th to August 15th. Okay, during the this period, they wanted to provide some more discounts like 10 to 15% on their each product. So product in the sense it could be a watch. Okay, it could be a TV, it could be any electronic items, it could be anything whatever they sell in their website. Okay, so during this period, okay, they expect a huge number of customers to their website. What is their requirement? First, why they are offering this? There is a business requirement. They wanted to get more business. Okay, first let's understand more business. Okay, they're expecting more business during these days. Okay, what is the requirement now? There, first of all, they are expecting more load on this, more load on this website, because they are offering the great discount, so they may expect a good revenue. So they have to ensure first. Second thing is more load on the website. Okay, so that means more number of users they are coming to accessing this website. Okay, then the website also should be available all the time, available all the time. Okay, with good response, with good response. Okay, now let's see. Okay, this is like something website they developed. Now if they're planning August 15th some changes and some discounts, they have to modify this website because there is a programming language behind this website. Okay, for now you know ignore what type of programming language it is. It could be Java, it could be .NET, it's a front end, it could be Angular, different programming languages in the front end and back end. Okay, that's not our focus. Okay, so now there will be a programming language behind this. Okay, it could be a Python. So there will be again in you have a UI and a backend, front end programming language and backend programming language you have. Okay, our focus is not on what type of language it is. Just you understand if you develop, if you are from the development background, if you are from the non-technical background, if you are from the IT background. Okay, you just understand there will be a front end and backend technologies. Okay, and there will be a database server. Okay, so generally these are three-tier technology. Let's say front end, back end, and the database. So these are the most required factors to develop any website. Okay, so there will be a front end, different programming language. Now you have Angular. Okay, like a few of them now are using back end HTML, Vue. They are different programming languages. And the back end, you all know Java, Python, PHP. There will be many programming languages. Okay, and databases also, MySQL. Okay, MS SQL. These are different databases. Okay, right. So now let's talk about the change. Why they need to change the website? Because during the August 13th, 15th, let's assume that they are going to offer some more discounts. That means whatever the products currently you are seeing the price, there may be a change because right now they're offering extra 10%. And then you may expect a 15% discount because this price cost is going to change. Okay, this cost is going to change. Now it's 10,799 if you are going to buy this Realme TV. Maybe they may offer more less price during that period. Okay, these are all the changes. Why organization they change the code frequently? It may be like this is one of the business requirement. Else something they wanted to introduce some new features. Okay, this is a like business requirement. Okay, so they are the developers, they are writing the code and developing this website. Now this is a change. Okay, how you are going to manage the change? Because there will be a list of products, they will offer some discounts. Ideal price will be different. Okay, ideally right now they are selling 10,719, but during the offer period they will have a less price. Then post that August 15th, again they have to revert the change. Again they have to change the price back to 799, or else it could be 11,000. There is a more demand. If there is a huge demand, then they may increase the price. There is a less demand, they may bring down this price post the August 15th. Okay, this is a one business use case. Now we'll take this example and try to understand what exactly the DevOps. Now they wanted to change. Okay, so they are writing this code and storing in somewhere in the centralized location. Okay, there will be a source code management. We generally call it as a version control system. Okay, because there will be a programming logic behind all this user interface, whatever you are saying, and whatever when you are clicking the cart, it is going and it is showing the cart. Okay, so there will be a programming language, front end, back end, and database services are involved. Right. Okay, so how we are handling this front end and back end technical source code? Because there will be one service, there will be a multiple services in the back end. They may use to for this website there will be a multiple, there might be a multiple programming languages, backend services behind that we don't know right now. So how we are managing? Okay, the first thing is whenever you plan a change, okay, the developers, what is the current state? Why you need to manage the versioning? Now let's understand this use case. Why you need a version control system? Okay, because now you are selling the price and this price. Okay, and during the August 13th to 15th you wanted to sell it with the low price, and then post August 15th, based on the demand, either may increase or you may decrease. Okay, now this is the change. If you wanted again keep the same price, you need to again roll back your code and keep the same changes, and then you need to know after some days, let's say August 13th, 15th, you offered some discounts and these are the products, different products, and next time in the September again they wanted to give the same difference but on the different products. How they are going to identify what are the products this time they are offering? Okay, there should be a tracking mechanism. So what are the changes that we have made to the current system, because this is the current state today. So if you are making a changes, you need to track your application code, what are the programming changes you have done. Okay, so you should be easily able to manage your code. Again, if you wanted to go back to the same change, you increase the price based on the demand. Let's say based on the demand, you increase the price to 10,799 to some 12,000, but nobody is willing to buy that price. So after some time, again, you thought of rolling back this change. Again, you wanted to keep the same price. If you're not managing your code, so you don't know what are the changes, again, you have to rework on changing this code and reverting back to the same price. So these are the challenges that you have in the current IT industry when you are working and developing any application. So for that reason, okay, so first we start with the source control management. Okay, it's a version control system. There is a code change. If you're modifying some name to, let's say it's a Realme and you just wanted to some MI or different anything, if you wanted to change the price, there will be a change. Okay, so you need to be tracked. That's why it's a version control system, source code management. And we have a different types of tools that are available in the current IT industry. Okay, plus I will just give a name. Okay, what is a version control system currently we are using is a Git. Okay, is a Git. So where if any developer pushes the code, it will show you all the changes. Right now, let me show you one example how it is going to change and how it is going to track. Let me show you just as an example. Okay, like this is assume that let me change my branch. Again, we will discuss about what is the branch and what is a Git repository in our next coming sessions. But in this session, just try to understand what is a version control system and how we are managing. Okay, you see, so this is one of my repository. Okay, assume that there will be same programming code that is stored under this. Okay, assume that. Okay, I'm keeping all my project development related code under this. Okay, I have some files. Okay, I have some structure. Okay, this is my source code repository. Assume that the user whatever you are seeing here, Flipkart, assume these are the files related to your front end application. Okay, I have stored here and doing some modifications and modifying. Okay, so how you are going to address this whenever there is a modification? So here it will show what are the files that are added, because what are the commits latest. This again we will discuss. So in the source code management, you can easily identify what are the changes that you have done to that your source code. Okay, if you see here, I have updated my GitLab YAML file. Okay, what is the update? If you want to, you can open and see what is the change that I have made it. Okay, here it is showing is a minus is a deletion, plus is a addition. So this is a kind of a code change I have made. So you can identify what are the changes that you have made to your source code. Okay, again we will discuss further more in our coming sessions. Now our focus is only just to understand what is a version control system that we need. Okay, so these kind of changes you can identify and you can track And tomorrow, if you wanted to roll back easily, and you can go to that stage and you can roll back your website if you wanted to revert, so that you can easily understand the functionality of your program. This will be more helpful for the developers. Okay, being a DevOps engineer, we should know how the version control system works, but it is more going to help to the developers what are the changes they have made, and it is for your source code management. Okay, now in the market, okay, so we have a different source code management tools. Okay, either it could be GitHub. Okay, either it could be a GitLab, either it could be whenever it is coming to AWS code commit is one of the source code control management system. Okay, either it could be a Bitbucket. So these are the different tools that currently exist in our market. Okay, these are not limited, there are again we have a many, but I'm just giving you some example. So this is how we'll start with version control system management. So where we track the changes to the source code. So any questions here coming to the source code management? Any doubts? Then I will move to the further. Just give me a message. So if you are good. Okay. So I assume no questions. Okay. Next. So once you develop this code, okay. So once developer they written some code, so how they are going to again deploy directly on this system. So again there will be a different stages involved. First, whenever is there any programming language, okay, let's try to understand how you are going to deploy your application on a system. Okay, once you develop any web application, it's not our job, but you need to understand build part we have to take care, but you understand the process. Okay, whenever any developer, okay, they write the code and commit to the any of the Git repository, so there again the change management will be happen. And then next, if it is a Java program, you can not directly deploy the application on any of the system. So there will be a process if you wanted to deploy of the programming once you have written. So you have to build your application so that it will compile your source code and it will generate one the jar file. Okay, this will be your final version of your code, the final the binary of your Java code, and then you will go and deploy on your either Apache web server, so that is a process for the Java. Okay, if it is a node backend, so you have to create a npm build, okay, and then you have to deploy on your respective web server. Okay, if it is a Python, there will be a different approach. Okay, if it is a Golang, there will be a different approach for the build management. Okay, so here we need to talk about the building your programming. So here we are talking about this managing your source code, and once your code is updated in your central repository, if you wanted to go with your automated deployments, okay, and these are also should be done automatically. If you are taking care of all these changes manually, it will take a longer time, and we unable to achieve the changes, and we will not be ready for your August 13 to 15. So if you wanted to achieve that time, there will be an automation again is involved. That's why you're talking about the CI/CD approach, continuous integration and continuous delivery and deployment. Okay, so this is all comes under the CI/CD approach. Okay, right. So again, Golang, it's a Go build. Python, it will be we need to install the packages. So there will be a different approaches for the different applications. So being a DevOps engineer, you must know how to build a Java application, how to build a Node application, how to build a Python application, how to build Golang application. Okay, and how to, these are the backend programming languages, and how to build your front-end application. Once developer commit the code to the Git repository, how you are going to take that source code and how you are going to deploy on a system. So this is the approach you need to understand. Okay, so for building the Java, so there will be again different tools that we have. A Maven, somebody use Ant to build your your Java application. Okay, but Node, it's only a unique that we need to use npm. Okay, and Python there will be a command to, it will only the text packages. And Golang, it's having a Go build to build your programming language. So you have to focus on this programming language, and you need to understand the build and deployment approach. For Java application, how we are going to build and deploy, and for Node application and Python and Golang. These are the popular languages. If you go to the any organizations, you may involve with this different. Okay, whenever it is coming to this UI, yeah, it's again Angular. Okay, or as I specified above, it could be a Vue. You forget about HTML. Okay, there won't be any build process, directly we can deploy. Okay, Angular, Vue, depends. Okay, and React. So now how we are going to automate this build management? Normally, whenever a developer build application, earlier we used to hand over whenever there is a deployment to the production or any QA environments. Normally developers hand over the files to the operations team. Now we here understand why the operations team is involved and what is exactly the development team is doing. They committed the code, and the developers will have access to, and listen here, okay, so developers will have access to only their dev environments. They are only responsible for developing their code and testing the application in their development environments. Okay, environment is like it's a servers. These are all the servers. Okay, for now your understanding, call it as environment is okay, there will be a server, we will go and deploy the application and test. Okay, you will be having a different servers in your organization environments. You have a dev environment, you have a QA environment, you have a a pre-prod environment, and you have a production environment. Okay, so here, ideally in every organizations, developers will have only access to make any changes to their code and to test in their development environment. Okay, they changed something. Now this is the production website. Now whatever you are seeing here, the Flipkart is a production website. We are using. We are the customers to the Flipkart. We are using. So this is a production URL. So the Flipkart.com currently what you are seeing is the production URL. Internally they might have like a dev.flipkart URL, qa.flipkart URL, uat.flipkart URL. Okay, so they might have internally. Okay, because before they move directly to Flipkart.website, the major website, so internally they will test their application code in different environments. Okay, different environments. So here only up to here they will have access. Okay, then again they have to contact the operations team. Please deploy this on QA. Then QA team, what they will do, again they will do some UAT, they will test for the application testing, all the functionality is working, and they will do the testing. And again, if they find any bugs, again they will go back to the development team and they will work on again the changes, and they will deploy this and they will verify. And again we have to, the operations team, they have to deploy in the QA environments. Once it is passes, again they will deploy on the pre-prod. Again there will be a testing for the application if it is working on perfectly, and again it will be say move to the production. But here the operations team involved, because development team access is very limited to their dev environments. When the code is moved to the production environment, the development team don't have any access to touch the production environments except the product support team. Okay, so nobody will be having access, right? So there will be a gap, there will be a delay, to move all these environments if the operation team should be available. Okay, and when you are moving and there will be a changes, okay, here development team, they need operations team to update this application in all the servers. Okay, and also there might be a challenges. Okay, in dev environment they might not see any issues with the environment, with the servers. with the functionality. Okay, and when they move to the QA, there might be a server issue, there might be a disk space issue, there might be application issue. Okay, it may similar with the different environments. Again, there will be a delay whenever coming to the resources side. Okay, so these are the many challenges. Again, they have to roll back the changes if there is a issue with the server, so the testing may be delayed. You deployed something on QA, then it is broken because of the operating system update. It is broken. Again, operations team have to build a separate system, and then again they have to set up all this. Okay, there might be delays also. Okay, so now that's why we are discussing about it's a combination of developer and the operations team, how we are going to take care of this deployments and the operations side. Okay, we are filling that gap, and we are trying to avoid the delays along with the help of the cloud computing. How it is going to help to avoid the delays in the deployments and the delivery, that we'll try to understand. Okay, right. So here you have to have a build system. So earlier, they have to build the application manually using the tool. Somebody operations team, they need to take the code. Else somebody will build that and share with the jar file, respective jar file with the operations team. Then operations team will take care of and stop the service and deploy that into the system. Then again, this is the same repetition for every environment. There will be a delay in the delivery. So if we are doing like this and if you are wasting the time here, then it may take more time what they are trying to schedule this like August 13 to 15. Okay, so we have a very short time, so they need to achieve. So to avoid these delays, as per if it is a business requirement, if it is a the application functionality requirement, so we need to avoid the delays in the deployment and delivery. Okay, so our scope is you need to know how to build the application. You don't bother about how to write a Java programming, how to write a Node programming. You should know how to build a Java application, how to build a what are the programs I have specified here, languages. Right. Okay, so you are building, every tool have its own mechanism, every programming language it's have own manual way of mechanism. Okay, but now how to automate this? Because we wanted to avoid the delays, because if you are not achieving within the period of time, then this Flipkart is going to lose the business. Then Amazon is having also the similar type of, because one of the competitor, there will be always a competition between these Amazon and Flipkart. They may get more business, they lose this opportunity. Okay, right. So now how you are going to automate this build process? Because once you develop the change should be automatically deployed to avoid all these changes. Okay, so what type of the build tool, the integration tools that you have currently in the market are the popular? Okay, so the almost in the market 80% now still we are using the Jenkins for CI, and sometimes CD also we are using. Okay, so our focus is on like Jenkins. This will take care of your source code, and it is having different plugins to work with different programming languages. Okay, now this is Jenkins is one of the integration tool where it will tag your code and it will build, and also it will deploy on your source environment. Okay, right. Again, as part of the build, developer returns some code. There might be some vulnerabilities because when you are developing a code, and that should be secured, it should not have any loopholes in their code, so that someone attacker will access your code and he may destroy your application. So while developing your application, you need to also take care of your code quality and also the security. So once you build your application, again there will be another step is code ensure that code is quality code. Okay, so if someone is cleaning our home, they are not cleaning properly, then our health will be impacted. Similarly, if someone is developing the application, the code also should be qualified. There should be a quality code. It should not have any chances of entering some hackers into your application and doing some changes that may lose to the business. Okay, code quality checks. So for that is also automated. Okay, that is also now automated. We have a tools like SonarQube, so where you can do automated code quality scans for your application. Okay, there are several processes involved as part of the build. Okay, and also is there any vulnerabilities? Okay, code quality and vulnerabilities. So this is also the builds. If we are doing all these steps as part of the build system and before to the production deployment, it may impact a lot of delays. So that's why this process is automated. Okay, so here we have a Rapid7 and necessities scans in the real-time industry. Why I'm talking about this? As part of the build system. Okay, once you done in the Jenkins, you create an application build. Post build, we directly go and do not deploy on our production systems. It should pass the code, whatever the code that you have built. It should pass at least minimum. It should reach 80% of the code quality. Otherwise, they won't approve the code. The higher management, those who are managing the development team and who are authorized to approve the code, they are not going to approve. It may different from one organization to another organization, but most of the cases I have seen, if the code is reaching 75% to 8%, then they will approve the code. Again, there will be a delay if this is not there in the DevOps process. There won't be a quality website. You may see, you may experience some issues with this website. You're trying to purchase this as part of the period 13 to 15th August, and when you're trying to buy something, it is not even responding, maybe because of the functionality issue. Assume that there will be. Okay, so that's why there is a process. Okay, so once you pass these stages, okay, your integration is done. Okay, and you need to so AWS side I'm speaking, because now how we are going to do this the same on the AWS side. So AWS side, so here for versioning system, we are talking about the AWS code commit. And we also have a different competitors in the market, different service providers, and similarly for continuous integration also. Okay, so we have a AWS code build. Okay, we have a AWS code build, which is completely replacing the Jenkins CI. Not only that, though even GitHub is also providing your integration facility. In GitHub, you have actions that will take care of same your build part, and GitLab also will have its own CI mechanism. It is directly, you don't need even Jenkins to create some builds and deployments. So GitLab is having its own mechanism. Okay, why we have this continuous integration everywhere? Earlier, actually, we used to have only work with Jenkins, but whenever this cloud computing came and this automations, now the DevOps is more popularized. Everybody is trying to shape up their application. They are trying to, this is source code management. If it is having a capability to automatically build and deploy, if this is having the functionality, so that this company is having a more business. So most of them are they don't need to management. Coming to the management side, for source code management, I have to use GitHub. Again, for integration, I have to use Jenkins. Then I need to look for somebody who knows the Jenkins. Okay, then again they have to hire someone. If somebody knows in GitHub and how to manage the source code repository management, how to write the pipeline in GitHub, they will hire for them. Okay, so like that. So AWS code commit from the AWS side. And here, whenever coming to the integration side, AWS is having a code build. Okay, these are the AWS native services. 100%. Okay, this AWS code will not be there everywhere. Okay, 100% Jenkins you don't see everywhere, but this is a common. 80% of the market is using. If you are working on the AWS side, you should know how to build this, so that you are good enough to handle if you see Jenkins and if you see AWS, you can do both. Okay, so once you build your application, and how you are going to deploy your application in different environments, multiple environments. Okay, coming to the multiple environments, so And sometimes we may use Jenkins also. We'll install some SSH plugins and it will connect to the system and it will go and deploy in the respective server. Okay, it is also having, we need to install different plugins if you wanted to use Jenkins in a, there are a lot of features in the Jenkins. That's why we are still discussing about the Jenkins. You can integrate AWS code build, you can integrate GitHub plugin, you can integrate Sonar Cube. It supports for everything. AWS, if you have a Azure, if you have a GCP, if you install a respective plugin, it will go and take. That's why those who are exist already on Jenkins, they are not moving away. Simply they are installing the plugin which is required. Simply it will take care of integration and we need to add the plugin. Then it will start from the AWS side. Okay, so coming to the deployment side. So from AWS side, we have one more tool, AWS Code Apply. What it will do, it will take your the build file. Okay, once it is passed all these two stages, code quality and vulnerability scan, it will go and deploy on your respective environments, respective servers. Okay, and there will be a one more step is like configuration management. How you're managing your environments which are related to the application servers. There will be a patching. You need to set up some dependencies like and last time there is a Python 2.7 version. Now they rolled out. Now it is, there will be no more support and you have 100 systems to update your Python to latest 3.7. So how you are going to automate that? Okay, so configuration management tools, again there will be a huge demand in the market where you can work with configuration management tools to automate your tasks and multiple systems. Okay, so like in the market we have Ansible, Chef, Puppet, SaltStack, and from AWS service it is a SSM. Okay, AWS also it's have a own configuration management tool, SSM. So this will help, like let's say you wanted to do a patching for your application environments, 100 systems you have, so you need to manually log into 100 operating systems and manually update. No, it will again a time process. So again every company will have different tools. These are the popular tools I have specified, Ansible. Okay, so you can use this tool to start patching in 100 systems. Okay, right. So far this will be so here as part of this example, so we have covered source code management, continuous integration, and continuous deployment tools. Now how we are going to achieve the availability and scale performance? Okay, so far we are only tried to understand how to manage and how to deploy, okay, automatically, okay, with the help of the CI/CD approach. And what is the dependency between the developer team and the operation team? So what would be the job of the DevOps person? The DevOps person is going to take care of once the developer commits a code, and you need to be responsible for managing your GitHub or the AWS code commit, and you need to manage your the programming languages builds. Okay, once the build is generated, there is a one more part, you need to store that build. If it is a jar file, once it is created, you need to store again in the somewhere in the artifactory. Okay, like a JFrog. If it is AWS S3, we will store all our artifacts. Artifact is whenever you use a build, this will be your output file. That's the artifact. Okay, npm, there will be a dist folder or a build folder they create. So you need to store it somewhere, because if something is wrong, you need to roll back to the stage. Simply you take the file and deploy in your environment. Again, you no need to go through this all the changes. What are all the changes we have made since 2 to 3 months? If there is any issue, then you need to go back. So if you have a build file, simply you can go back and deploy the respective version. Okay, right. So now we discussed about, let me take this separately. Okay, so we discussed about source code management and what are the tools, and we discussed about CI and CD. Okay, and we discussed about the configuration management. See, these tools are there before the cloud computing. Okay, these tools are there before the cloud computing, except what are I have discussed in configuration management SSM and deployment side code apply, and this AWS code commit coming to the version control system. Okay, so now let's understand, and there will be one more part we need to discuss coming to the containerization part. Okay, containerization part. Okay, so we are talking about here the top. We are talking about the availability. Forget about the availability and performance. Okay, let's say you have a 3 to 4 systems. Okay, for your application, like one web application, 2 backend applications, and one web server and one database server. Okay, if we have this, okay, and the server is running with all the servers, because for same Flipkart application, if they are running in on premises, how they are going to deal the availability and performance. Okay, in August 13-15, they, so in some time almost total CPU and memory, okay, all CPU and memory got fully utilized. So there is a huge load on this all the servers, huge CPU and memory, 100% CPU, 100% memory. Okay, so this is only between, assume that August, let's take the scenarios. What would be the scenarios? They need high availability and the performance. Okay, normal utilization, you need a minimum performance, that is enough. But during this crucial period, okay, if you are targeting more business, you need to ensure. So before cloud computing, what they have to do is they have to purchase few more servers. Okay, let's say they will keep, they will add one more 2 web servers. They will add one more backend, 2 backend servers. They will add one more one database server. Assume that these are all physical or virtual machines. They have to purchase. So if Flipkart wants to they are targeting the business, more business in between only August 13 to 15, there will be an investment, because your website should be available and it should have a good performance. If you're clicking on particular product and it is keep on loading, next time you will never come to this Flipkart. It's always slow, and you start complaining that it is not even allowing to choose anything. That's why the availability and performance is pretty much important for the companies. Okay, right. So how they are doing is, so they have to purchase these servers, or it could be a physical or it could be a virtual machines. Okay, again we will discuss what is the physical machines and the virtual machines and containerization in detail in further coming sessions. Okay, so here they have to purchase and they have to add. Again, see, you are purchased, but if you wanted to make that as a web server, you need to install some dependencies and some configurations you have to make. There will be a time investment, and similarly to the backend and similarly to the database server, there will be some dependencies you have to set up. You cannot take the system directly and put as a web server. You have to install something that will take a lot of time. Okay, so here there will be a operating system is involved. So that's why now most of the cases, whenever it is coming to the DevOps for the containerization, mostly we are talking about the Linux operating system, Unix. That's why you need to have some operating system and user the skill sets. You need to know how to manage, how to deal with your systems, because these applications will be deployed on some servers. Okay, on the server will have some operating system. Okay, so mostly we'll target the Unix, that's Linux operating system. Okay, there you need to set up some dependencies and all. It may take, so there will be again a delay. They also, company also have to invest some amount of money. But how exactly they using this same configuration 24/7? No, 365 they don't need. They want high, they wanted to have a high availability, more performance during only this period of time. The rest of the time, okay, the currently what are the servers they are running, one web, 2 backend and 1 DB, it's fine, but only this period of time they want. So for that they are investing. There is an additional, they wanted to, they need to buy some servers. Again, they have to go through some approvals. Once you got the servers, again you have to do a setup. Okay, if you have a money also, they will purchase and they will have this servers 24/7 running 365 days. But how the company is going to optimize the cost? You are investing a lot to get some business, but you are not fully utilizing your infrastructure, the operating system, servers, whatever they have purchased. Only they need based on the like monthly, like they will try to offer like in some 3-4 days, at least hardly 10 days like that. But rest of the 20 days they are not using effectively 365 days. So how we are going to optimize the cost? Because if you wanted to buy something, if you wanted to provide something, you need to buy first. That is a capital investment for the companies. They have to invest a lot on the infrastructure side. That's why there will be a less margin on this. If they are investing something to provide this, assume that they have invested 40%, okay, and they have got only 60% margin. There will be only 20% margin they have got. 40% is again invested on the infrastructure. There will be a less business on the dates. So how they are going to optimize the costs on the investment, and how they are going to provide the high availability? Let's say they added 2 more web servers, but unexpectedly there is a huge load on all the servers. There are no servers left. Then what happened to Flipkart website? It is going to down. They lose the business. There is no point of we are talking about the availability. There is no scaling. If all servers are running highly available, there is no point of scaling, because you don't have enough servers, physical or virtual machines left in your organization, and you may end up with the business, and you cannot achieve this whatever you are targeting in 13 15. You are assuming some $1 billion revenue in this, you may not be able to achieve. And also it is going to impact very bad on the company, because if Flipkart website is not working during the time, then we start complaining it's waste of time. So we'll go who is providing the better performance. That's why these are the key factors for every company, any website. Just only I'm giving why these two, because you mostly deal with this website to purchase something. That's why I took this as a use case. We don't like if it is taking a longer time to open, usually we don't like. Let's take an example of IRCTC. How much you're willing to buy the tickets between 10 to 12? Okay, when you log in before 9:58 to the website, if it is at 10, your login session will they flush your login sessions. 10 o'clock, if you sign in, it will take a few minutes, because there will be a huge load on the IRCTC website between 10 to 12. Right. So now we understand the challenges what we have in on-premises before cloud computing. Okay, so how this cloud computing is going to help? How this cloud computing is going to help to the application? Okay, so there is one more part. Then we will go to the cloud computing. So there will be a containerization concept, Docker and Kubernetes. Okay, so here we are talking about the servers. Okay, adding multiple servers and setting up the application. Okay, performance, because you need to see if it is a physical or virtual machine, every time you need to install some dependencies which are related to web server and for the backend server. Okay, so every time you need to spend some time. Okay, so if it is a virtual machine also, there will be some dependencies that you need to have to set up your applications. But whenever it is coming to the containerization side, it will be like a bundle package. It will be a bundled package. Whatever is required for your web application, what is required for your backend. Okay, it is a complete package. It's like a Docker image. We will call it as a Docker container image. Okay, it will be, we will create like as a package. It will have whatever is required for your a basic operating system, and required what is only required, that will be there, and the dependencies libraries required for the application. Okay, and if you follow that containerization steps and create your application, you take that Docker image and deploy on any containerization platform. any containerization platform, it will work, and it will help us to address these issues time. Okay, there will be a platform dependency. You need to set up something operating system. It may take a good amount of time, and there will be issue with the server. Again, you need to bring back one more server, and you need to install the dependencies. Again, it will take a lot of time to bring up your application. But if you go with the containerized image for your application, okay, you can, it's a platform independent. You can deploy on any containerization platform, and very quickly you can bring up your application. So that's where this containerization came to the picture after the virtualization. Okay, first of all, there is a physical servers. So on the physical servers, what is the issue? You cannot, if you install all the applications on the same server, and one of the application is taking 90% CPU, it may impact the other applications also. Even if it is taking it's a single point of failure. One application is taking, if you install everything on a physical server, then all applications will goes down. Again, we will go in the operating system, what is a physical server and virtual machines and the containerization when we are going to talk about the containerization. Okay, so there we will discuss individually. This time we just understand only the term, okay, containerization. Okay, to address the issues in the physical machines, now virtualization technology came. In virtualization also there are some issues whenever coming to the application isolation and the performance. The containerization came. This is the era. Traditional era is physical, and again virtualization era, and then the containerization era. Now we are into containerization era. So this Docker and Kubernetes, Docker is we use the application to containerize, and the Kubernetes is like, if you have 100 applications related to Docker, how we are going to manage your 100 Docker containers? You need some management. Okay, simple. I'm just giving in a simple terminology to understand. And then again, I will show you exact difference. And you wanted to scale. If container application goes down, again you wanted to run one more container automatically. So for that we use Kubernetes. Okay, for the management of your container, simply orchestration. Okay, so where we will again talk about the containerization. Why? Because as part of your this build process, once your build is deployed, where you are going to deploy your application? Is it on the physical server? Is it on the virtual server? Is it on the containerization? If it is a containerization, if it is a Docker host or a Kubernetes, you should know, because for each type you have a different deployment process for deploying your application and managing your application. Okay, yeah, so this all exists before cloud computing. Now cloud computing came to provide the availability, scalability, and pay as you go model. Pay as you go model is like if you wanted to travel from one location to another location with 4 of family members. Okay, so you're thinking about purchasing a car to travel at least 4 persons comfortably. For that, what you have to do, at least you need to have an initial capital amount, then you will go for the loan. Okay, and then you will buy a car and keep it home whenever there is a requirement, hardly monthly, thrice or four times you will go out with the family, only on that purpose. What you are doing, monthly hardly you are traveling along with the family 3 to 4 times, but you are investing a minimum car budget 5 lakhs and you are paying the loan. This is a problem. But now this Ola, Uber came into the world. You don't need to buy a car if you wanted to travel from source to the destination, and you pay for that. How much time you're traveling, and now with a single click in the majority of available location, you're getting a cab within 10 to 15 minutes. Assume that it's on demand. On demand, you're getting the cab and you're boarding into the cab and you're going to the destination. You're paying only for that. You're not even no need to buy the car. If this is the concept, pay as you go model. Okay, pay as you go. Now cloud computing also works with a similar order. Let's say here we are talking about the availability. Okay, in August 13 to 15, you need you are expecting some to additional to backend and to one database servers additionally. But if it is with the case with the on-premises, you need to buy extra servers. And if you are extra servers, you need to keep that permanently. If you're taking a rental also, you take the rental, you have to assign to somebody. Somebody is again taking care of that. There's a different story. Okay, if you are buying, okay, again, it's unnecessary investment. After this, there won't be much use. But here, whenever there's a cloud computing, okay, we are yeah, let's discuss here only. Okay, you have a scaling capacity. Okay, if all servers are running automatically, more number of servers will be launched based on our configuration. We need to configure how much minimum servers needed, how much maximum is needed. Okay, and you don't need to worry about the availability of the servers in your organization. Okay, it automatically scales, and you only pay, let's say, only 13 to 15, 2 days. You created additional 2 web servers, additional 2 backend servers, and these are all involved in automation. Okay, again, those who are taking care of this automation in cloud also, who is taking care of this automatically scaling part and this part? Only we DevOps engineers have to take care of this part. Okay, you have to return the automation scripts and templates. Okay, so here, so you have a good amount of hardware. You don't need to buy any single, because Ola have a number of cars. You don't need to buy, simply use it and pay for that. And here also you don't need to buy any servers. Simply take launch this virtual machine, or the content, launch the virtual machine if you need it. And if you're using for 1 or 2 days, you pay only for that. Then server will be terminated automatically. If you have that kind of automation configured, you pay only for that. You don't need to even buy and take that burden. Okay, if you're paying only for 2 days, so during these business days there will be a less investment, so your investment growth is more. You are getting a more business. Assume that here you got the 60% revenue. Okay, so earlier in on-premises you're investing only 40% on your infrastructure, buying all the servers permanently and keeping. So your savings are only 20% for the company. Okay, but if you are going pay as you go model in the cloud, this is only, I'm just assuming, okay, it's not only 20%, it's not only 15%, it's just based on your configuration again. Okay, assume that there will be only there is a 50% reduction, so 20% only you are investing out of 60%, so there will be a 40% of benefits. Like this, the organizations are getting more business. If you are they are moving to the cloud, you need to understand why the people are moving to the cloud, because this is servers also you have to manage, and you need to have some data center to manage the servers, and you need electricity 24/7 running, power backup you need, and ACs you need to cool your servers 24/7. This is additional cost again for the companies. Okay, if you have a car, you need to take care of your own insurance. You need to responsible for the maintenance. Okay, so these are all will be part of the maintenance. Okay, if you don't have any data center in your organization, your space will be, you can use it for some other setup, and there will be no power requirement 24/7. You don't need to buy any additional electricity, and you don't need to maintain data center administrators to manage your data center. Okay, because somebody is owning that. Amazon, AWS, and Microsoft is Azure, and Google is having GCP. They all having a data centers. Cloud computing is nothing but it's a remote location, remote data center. They are managing our infrastructure. We don't need to bother about that. They are purchasing everything. They are doing the business. We only need to use and pay for that. Okay, so then again we will discuss in detail about the cloud computing. So that's why there is a huge benefits if any companies moving to the cloud. In this way they are getting the more revenue. That's why nowadays everybody stopped creating purchasing servers unless there is a big requirement. Okay, yeah, so that's all about that's just introduction. So as part of the introduction, we will go all our AWS. We will go through cloud computing. You will get to know, in AWS what is AWS, and what are the services, and what is auto scaling, availability, and all we will discuss. And coming to the DevOps side, we will discuss about continuous integration tools, continuous CD tools, configuration management, source code management. This is just a use case I took and just explained. Any questions here? So that we can wind up the demo.